Every day, millions of people open their laptops, start working, watch videos, create content, or connect with the world through a device that fits inside a thin, lightweight frame. But behind this simple design is one of the most complex manufacturing processes in modern technology. A premium laptop is not created in a single step. It is the result of thousands of precise operations where advanced machines, microscopic electronic components, and skilled engineers work together to transform raw materials into a powerful computing device. Inside a high-tech manufacturing facility, every detail matters. From the aluminium body that protects the machine to the tiny components hidden inside the motherboard, every part must be manufactured, assembled, and tested with extreme accuracy before the final product reaches customers. So how does a simple collection of materials become a powerful laptop used by millions of people around the world? The journey begins with the arrival of raw materials. Large quantities of specialized materials enter the factory, including aluminium alloys for the outer chassis, glass for the display, silicon-based electronic components, copper for electrical connections and cooling systems, and lithium-based materials for the battery. Although these materials may look ordinary, they are the foundation of a highly advanced machine. Before production begins, every material goes through strict inspection to ensure it meets the required standards for quality, durability, and performance. For premium laptops, the outer body is one of the most important design elements. It must be lightweight enough for portability while remaining strong enough to protect the sensitive technology inside. The process begins when aluminium blocks or sheets enter precision CNC machining systems. These computer-controlled machines remove excess material with incredible accuracy, slowly shaping the raw metal into the detailed structure of the laptop chassis. Unlike traditional manufacturing, where human workers manually shape materials, CNC machines follow digital designs and create identical components thousands of times with extremely small tolerances. As the machines cut through the aluminium, every movement is carefully controlled. The cutting speed, pressure, and position are monitored to ensure the final structure meets exact specifications. After machining, the chassis moves through cleaning and finishing processes. The surface is polished, treated, and inspected to create the smooth premium appearance that customers expect from high-end devices. At this stage, a simple piece of metal has been transformed into the foundation of a modern computer. But the outer body is only the beginning. The real intelligence of the laptop comes from the electronic systems hidden inside. The motherboard is the central nervous system of the machine. It contains the processor, memory, storage connections, and thousands of tiny electronic pathways that allow the laptop to perform complex tasks. Creating this component requires extreme precision. Inside specialized electronics facilities, robotic machines place microscopic components onto circuit boards. These automated systems can position thousands of parts with accuracy far beyond human capability. Tiny chips, connectors, and electrical components are carefully arranged before moving through advanced soldering processes that permanently connect them to the board. At this scale, even the smallest mistake can affect the entire device. That is why automated inspection systems examine electronic components throughout production. High-resolution cameras and testing equipment check the placement, connection quality, and performance of each motherboard before it moves to the next stage. The processor and other semiconductor components are then integrated into the system. These tiny chips contain millions or even billions of microscopic structures that allow the computer to process information at incredible speeds. Although users see only a thin laptop on the outside, inside the device is a highly complex network of technology working together in real time. Another major component is the display system. A premium laptop display requires multiple layers working together perfectly. The screen includes advanced panels, protective glass, lighting systems, and electronic controls that determine brightness, color accuracy, and image quality. During manufacturing, display panels are carefully assembled and tested. Automated systems check for imperfections, measure color accuracy, and ensure every screen meets strict quality requirements. The keyboard and trackpad are also manufactured with extreme attention to detail. These components must provide a smooth user experience while lasting through thousands of hours of use. Machines install individual parts, test movement, and verify that every key and sensor responds correctly. Inside the laptop, another major challenge must be solved: managing power and heat. Modern laptops contain powerful processors that generate heat during operation. To maintain performance, engineers install advanced cooling systems using components such as fans, heat pipes, and thermal materials. The battery system is also carefully designed to provide reliable power while meeting strict safety requirements. Every internal component must fit perfectly into a limited space. Engineers must balance performance, battery life, cooling, and the thin design that customers expect from premium laptops. Once all major components are ready, the final assembly stage begins. The motherboard, battery, display, keyboard, cooling system, and chassis are brought together on the production line. Workers and automated systems carefully connect each component, secure every part, and complete the transformation from individual pieces into a finished laptop. This stage represents the moment when thousands of separate components finally become one complete machine. Before leaving the factory, however, every laptop must pass through a series of demanding tests. Quality control is one of the most important stages in premium manufacturing. Machines test the durability of hinges, the accuracy of the keyboard, the performance of the display, the efficiency of the cooling system, and the overall reliability of the device. Performance tests ensure the processor, memory, storage, and software systems are working correctly. Thermal testing checks how the laptop handles heat during demanding tasks, while battery tests confirm that the power system performs safely and efficiently. Some factories use advanced automated inspection systems that scan finished laptops for physical defects, incorrect assembly, or performance issues. Only products that meet strict standards continue to the final stage. After approval, the laptops move to packaging. Automated systems carefully clean each device, apply protective materials, add accessories, and prepare the final packaging. Labels, product information, and tracking details are added before the laptops leave the factory. From there, finished products enter global distribution networks. They travel through warehouses, transportation systems, and supply chains before reaching stores, businesses, and customers around the world. The journey of a premium laptop is a remarkable example of modern manufacturing. What appears to be a simple device is actually the result of advanced engineering, precision robotics, semiconductor technology, and thousands of carefully controlled decisions. Every aluminium surface, every electronic connection, every display pixel, and every software test represents a small part of a much larger process. Behind every laptop is a factory where materials are transformed, technology is assembled, and human expertise works together with automation to create the computers that power modern life. This is the hidden world inside a premium laptop factory, where raw materials, microscopic components, and advanced manufacturing systems come together to create one of the most important technologies of the modern world.